Alright everyone, in this video today we are going to be looking at differential equation, and this form of differential equation that we are going to be looking at is equation reducible to homogeneous form. So we are going to do that using this as an example. So we have the y dx equals 2x plus 9y minus 20 all over 6x plus 2y minus 10. Now this equation is non-homogeneous, so we cannot separate the variables. We cannot use the separating variables method. So what we do simply do is to reduce this equation to homogeneous form. Then we can then separate the variables. So let's get this done now. We are going to reduce this by using substitution. Now we're going to substitute that x is equal to x plus h and y equals y plus k. Now what we simply do is to look for the value of h and what? K. So sorry, this is going to be in caps letter. So we have x equals x plus h and y equals y plus k. So we are going to solve for the values of h and k. Now how do we do that? We are going to do this for the numerator. For the numerator, we are going to have a h plus bk plus c equals 0. A, b, and c are just the constant here, 2, 9, and minus 20. Then for the denominator, I'm going to use the substitution ph plus qk plus r equals 0. So your p, q, and r are simply the constant 6, 2, and minus 10. So let's substitute this into this equation. Then we'll solve for solve for h and what? K. So if we do that, we're going to have a is 2 here, so I'm going to have 2h plus b is 9, 9k plus my c is minus 20 equals 0. So this will be transformed to 2h plus 9k equals 20. So I'm going to call this equation 1. Then I'm going to have, for this, I have 6h plus 2k plus my r is minus 10 equals 0. So I'm going to have a 6h plus 2k equals plus 10 equation. So I'm going to solve equation 1 and 2 simultaneously. So solving 1 and 2, solving 1 and 2, I'm going to have 2h plus 9k equals 20, equation 1. Then I have equation 2, 6, sorry, this is 6h. So I have 6h plus 2k equals 10, equation 2. So we can multiply equation 1 by 6 and equation 2 by 1. So equation 1 multiplied by 6 is going to give us 6 times 2. So I'm going to have 6 times 2 is, 6 times 2 is 12h plus 6 times 9. 6 times 9 is 54. So I have 54k equals 6 times 20. I have 120. So I'm going to multiply equation 2 by 2. So I'm going to have 2 times 6. I have 12h plus 2 times k, 2 times 2, I have 4k equals 2 times 10, I have 20. So we can subtract. So when I subtract, I'm going to have this, cancel out each other. 54 minus 4 is 50k. 120 minus 20 is 100. So when I divide both sides by 50, k equals 2. So let's substitute the value. So okay, substitute 2 for k in any of the equation. So I'll substitute in equation 2. You can substitute in equation 1, you get the same value. So I have 6h plus 2k, my k is 2, equals 10. So I have 6h plus 4 equals 10, and I have 6h equals 10 minus 4. 6h is equal to 6. Dividing both sides by 6, h is equal to what? 1. So we have obtained the value, we have obtained the values of k and h. So therefore, h is equal to 1, k equals 2. I'm going to keep these values somewhere so that we can make use of them in reference time, to make reference to them when we need them to substitute. So I'm going to put them here. So from our calculation, h is equal to 1, k equals 2. Now what we need to do is to substitute this for this in this equation. We are going to substitute s plus h for x and y plus k for y. Of course, we know that from this, s becomes x plus h is 1, and y becomes y plus 2. So we are going to substitute this for this. So I'm going to have, now this becomes the y, capital letter Y, the s equals 2 into x plus 1 plus 9 into y plus 2 minus 20 all over 6 into x plus 1. Of course, we will do upward here. So we are going to do that. I'm just substituting these values for x and these values for x and y. Plus 2. So my y is what? Y plus 2 again minus 10. So I'm going to have the y, the x. So let me just put this in place so that I can easily make reference to this. So the y, the x, capital letter S please, because we are substituting, equals 2x plus 2 times 1 is 2 plus 9 times y, I have 9y, plus 9 times 2, I have 18, minus 20. Sorry. All over 6 times s, I have 6x plus 6 times 1, I have 6, plus 2 times y, I have 2y, plus 2 times 2, I have 4, minus 10. Now you can clearly see from here that 2 plus 18 is 20, minus 20 is 0. So I'm going to be left with the y, the x, capital letter Y please, capital X equals 2x. So this plus this is 20 minus this. That gives me 0. So plus 9y all over 6x plus 6 plus 4 is 10 minus 10, that's 0. So I'll be left with plus 2y. So we have reduced this. We have been able to reduce this to this by substitution. Now we are going to have this. So let me call this equation 3 if you wish to. So now we are going to do this. We are going to use the substitution. So using the substitution, y equals xv. So we can use the substitution now for this. Y equals sv into this. So I'm going to have, so the y, the x is going to be product rule. We're going to use product rule. So this is u, this is v. Recall that the y, the x is equals to v du ds plus u dv dx. So I'm going to use this product rule for this. So applying that, I'm going to have the y, the s is v. So v is my v. So I have v du ds. I will differentiate. When I differentiate, it's just 1 plus this. So I have u, so x. So when I differentiate, I'm going to have dv ds. When I place is 1, so I'm going to retain dv x. Just like implicit function differentiation. It's implicit. So when we differentiate this, when I differentiate, I have 1. So I'm going to take dv ds. So I have the y, the x equals, so when I'm going to have v plus x dv dx. This is capital letters, please. So what do we do? Now, so we are going to substitute this and this into equation 3. So let me call this equation I, and I'll call this equation II. So substitute equation I and II into equation 3. So this is my equation 3. So dv dx is what? V plus x dv dx. So I'm going to have v plus x dv dx equals, I have 2x plus 9y. So my y is what? xv divided by 6x plus 2y into y. So my y is what? xv. So this is going to give me v plus x dv dx equals 2x plus 9xv all over 6x plus 2xv. So I'm going to take this one this way. So I'm going to have x dv dx equals 2x plus 9xv over 6x plus 2xv. When this goes here, it becomes minus v. So I think I'm going to rub off this. So we get this. Now, I'm going to have x dv dx equals, so the LCM of this and this is just like over 1. The LCM of this and this is 6x plus 2xv. So when this goes in, or when this goes into this divided by this is 1. When I multiply by this, I'm going to have 2x plus 9xv minus, so this or this divided by 1 is this. So I'm going to multiply it by this. So I have v there, v minus v into, so I'm going to multiply this by this. So I have 6x plus 2xv. Take note, I just took the LCM of this and this to be this. This, okay, this divided by this is 1. 1 times this gives me this. This divided by 1 gives me this. This multiplied by this gives me this. So when I open the bracket, I'm going to have x dv dx equals 2x plus 9xv minus, this multiplied by this is 6xv. This multiplied by this, minus times plus is minus. Then I have 2xv squared. This times this v. All over 6x plus 2xv. I'm going to have to rub off that again. So let's collect the line term. So I'm going to have x dv dx equals 2x. So I have 9xv minus 6xv are like terms. So 9xv minus 6xv is going to give me 3xv plus 3xv minus 2xv squared all over 6x plus 2xv. Now let's see. I'm going to have x dv dx equals, in the sense that s is common to this, this, and this. S is common to this too. So I'll have this. I'll bring out x into 2 plus 3v minus 2v squared divided by s is common to this, x into 6 plus 2v. So this will cancel out this. This will cancel out this. So we are left with x dv dx equals 2 plus 3v minus 2v squared all over 6 plus 2v. Now we have terms in v and x, so we can separate the variables now. So by separating the variables, we are going to do this. I'm just going to cross multiply. I'll lift this up, So I'm going to have x into 6 plus 2v dv equals 2 plus 3v minus 2v squared dx. So I can divide both sides now to collect terms that are like terms. Terms in v, terms in x. So I'll just bring this one down this way, and I'll bring this one down this way. So I'm going to have 6 plus 2v dv all over 2 plus 3v minus 2v squared equals dx all over x. So we can integrate this. Now what I'm going to do, I'm going to integrate this using using partial fraction. I'm going to integrate this. Normally if I integrate this, we're going to get a value directly, but I want to break this down so that you don't have to integrate this value here to split it into partial fraction. So I'm going to break this into partial fraction. So let's do this. So I think I have to write this somewhere else so that we can visit that again. So I have 6 plus 2v dv all over 2 plus 3v minus 2v squared equals the x all over x. So I'm going to integrate this or split this into partial fraction. So using partial fraction, I'm going to have this 6 plus 2v all over 2 plus 3v minus 2v squared. Now we have to factorize this. So I'm going to have this times this. Should be able to do factorization. So I'm going to have 2 minus plus 4v minus v minus 2v squared. That's the denominator. That's what I'm factorizing. So this is going to be, okay, so this is going to be equal to, let me do it this way, 6 plus 2v all over 2 minus 4v or plus 4v minus v minus 2v squared. Yes, so this will automatically take us back to this. 4v minus v is 3v, so I have 2, I have minus 2v, so this can factorize for this. So factorization should not be a problem. So what I've just done is factorize this, so we have this. Now what I'm going to do is this. So I'm going to write this, so I'm going to open this one up. So I'm going to have 6, so this is going to be equal to 6 plus 2v all over. So on factorizing this, I'm going to have, so what's common to this is 2. So I'm left with 1 plus 2v. And what is common to this and this is minus v into, so when this goes into this, I'm left with 1. And when this goes into the left with plus 2v. So it therefore means that this will be equal to 6 plus 2v all over. So I'll pick this 2 minus v. And I'll pick this, one of this, 1 plus 2v. So we have that. So what we'll now do is to look for, to split this now into partial fraction. So on splitting this into partial fraction, I'm going to have this 6 plus 2v equals, okay, all of this equals a all over 2v, 2 minus v, 1 plus 2v. So this is equal to this, a into 2 minus v plus b into 1 plus 2v. So what I've just done is I've changed this one this and this one this. I'm going to have 6 plus 2v equals a into 1 plus 2v plus b into 2 minus v. Now, we can start from anywhere. Let's put v equals 0. So if I put v equals 0, I'm going to have 6 plus 2 times 0 equals a into 1 plus 2 times 0 plus b into 2 minus 0. So I'm going to have 6 equals, so this is 0, 1 times a is a plus, this is 0 plus I have 2b, equation 1. So I can say that my a equals 6 minus 2b. So I call this equation 2. So let's move forward. So we can do that again. Put v equals 1. To put v, you can use cover up method to solve for this. You can also do this. You can put, I can put v equals 1 minus 1 over 2 to eliminate this. Any way you want to do it. So I started from 0, I am going to 2. So I have this, put v equals 1. So I'm going to have 6 plus 2 into 1 equals A into 1 plus 2 times 1 plus B into 2 minus 1. So I'm going to have 6, okay, 2 times 1 is 2, that's, I'm going to have 8 equals 2 times 1, 2 plus 1, 3. So I have 3A plus 2 minus 1 is 1 plus B, so I have B. So I got this equation. So now, from my first equation, I said that let my A equals what? 6 minus 2B. So I'm just going to substitute this. I'm going to substitute this for A in this equation. So I'm going to have 8 equals 3 into 6 minus 2B plus B. So I'm going to have 8 equals 18 minus 6B plus B. 8 equals 18 minus 6B plus B. So I have 8 equals 18. Okay, when I bring this one, I have minus 8 minus 18 is going to give me minus 10 equals minus 6B plus B. I'm going to have minus 5B. So I'll divide both sides by minus 5. My B is equal to what? 2. My B is equal to what? 2. Now we can get the value of A. So to get the value of A, I'm going to substitute B into this. So my A is going to be 6 minus 2 times 2. So my A is equal to 6 minus 4, which is equal to what? 2. So my 6 minus 4 is what? 2. My B is 2. My A is what? So therefore A equals 2. B equals 2. So we'll just go back to this place. So let me continue from this place. So I'm going to do this. So my fraction now, I have been able to split this into what? Partial fraction. This is what I want to split into partial fraction. This one. I have been able to do that. That's why I wrote it here so that we can continue from there. So this is going to be this. So it means that this is now equal to, so this is now equal to, so I'm going to have 2 and have what? 2. So I'll go back to this now. So I'm going to have 2 minus V dV. Remember we have the V here. Plus 2 over 1 plus 2V. dV equals the x all over what? X. So we are going to integrate this now. Now if I'm taking my time to break all of this. Now you're supposed to have known how to integrate all of it, but in this video what I'm trying to do is to take all necessary steps to integrate each part of it. So if I integrate this, so this is going to be something like this: 2 into the integral. Okay, I'm supposed to put this in an integral of 1 over 2 minus V dV plus 2 1 plus 2V dV equals dx over x. Now the integral of this, normally, you know, when you integrate, when I integrate this minus 1 here, I'm going to have 1 here. I'm going to have minus 1 here. So the inverse of that, so I'm going to multiply this by minus 1. So I'm going to have the integral of this is going to be minus 2 log, let me use ln 2 minus v. Now the reason, assuming I have plus here, there will not be need for the minus here, but because of the minus here, so I have minus 2 ln 2 minus v plus 2, then the integral of this, when I integrate this, when I differentiate this 2v here, I'm going to have 2, so I'm going to have the inverse of this on this side. Because of these 2 that here, because there's no 2, assuming there is 2 here, You know that it's 1 that's here. When I integrate this and I get 2 here, so I can just say 2 plus the integral of that. So I'm going to have 2 times 1 over 2. Okay, ln 1 plus 2v equals, so the integration of this is lns plus the constant c. So from this will cancel out this. So I'm going to have minus 2 ln 2 minus v plus ln 1 plus 2v equals ns plus c. Now I can rearrange this to be ln 1 plus 2v minus 2 ln 2 minus v equals lns plus c. So I can take this to become the power of this, right? So this become ln 1 plus 2v minus ln 2 minus v squared equals lns plus c. Now the beauty of this is that this is a constant. It can be in log form too. You can make this to be in log form. So let's continue. When we get to that stage, we'll check if we are going to make this in log form. So this is going to give us, so if you apply the